The sun is on fire. That is what you were taught. That is what every human civilization believed for the entire length of recorded history. The sun produces light and heat. Fire produces light and heat. The connection is obvious. The word burning is not an accident. It is the most natural description in the world for something that radiates with such intensity you cannot look at it without damaging your eyes. It is completely wrong. Not approximately wrong. Not wrong in the way a simplification is wrong when pushed too far. Wrong at the root. The sun has never burned. Not once. Not for a single second of its 5 billion year existence. The process that powers it has nothing to do with combustion. No oxygen. No chemical reactions, no flame in any sense the word has ever been used. What it is doing, instead, is one of the strangest, most precisely understood, most consequential processes in the universe. A process that took physics until the middle of the 20th century to work out. A process whose rate is set by one of the fundamental constants of nature. A constant that, if it had a slightly different value, would have made the sun burn out before complex life had a chance to begin. And a process that Feynman spent years building the quantum mechanical foundations of, without ever setting out to explain the sun at all. Pull the thread. The fire story unravels entirely. What replaces it is better. Here is the precise problem with the fire picture. The most energetic chemical reaction available is hydrogen combustion. Hydrogen burning and oxygen. The reaction that powers rocket engines and hydrogen fuel cells. It releases roughly 140 megajoules per kilogram of hydrogen, a large number by chemical standards. The sun has a mass of about 2 times 10 to the 30 kilograms. It radiates at a rate of 3.8 times 10 to the 26 watts. If the sun were powered by hydrogen combustion, the very best chemistry can offer, calculate how long it could last. The answer is 15,000 years. Not 5 billion. 15,000. A chemical sun would have gone cold before the first human city was built. Lord Kelvin ran this calculation in the 19th century, using gravitational contraction rather than combustion. The heat released as the sun's own gravity compresses it, and got a more generous estimate of perhaps 100 million years. Still catastrophically wrong. Darwin's geology required hundreds of millions of years for life to have evolved its observed diversity. Kelvin and Darwin were in direct conflict, and neither was wrong within their own domain. Something was missing. That something was nuclear physics, and specifically the discovery that nuclear processes release energy at a scale roughly 1,000,000 times larger than chemistry per reaction. Not a small improvement, a millionfold improvement. The gap between a chemical fire and nuclear fusion is the gap between a candle and a hydrogen bomb. And the sun has been doing the hydrogen bomb version continuously and steadily for 5 billion years. The fire picture was not just wrong about the mechanism, it was wrong about the timescale by a factor of 300,000. At the core of the sun, hydrogen is being converted into helium, but the mechanism is not obvious, and the first thing you discover when you try to work it out is that it should be impossible. Hydrogen nuclei are protons, single protons with positive charge. To fuse, 2 protons need to get within about 1 femtometer of each other, 1/1,000,000th of a nanometer, so that the strong nuclear force can bind them. But 2 positive charges repel each other, and the repulsion grows stronger as they get closer. The energy barrier they must overcome, the Coulomb barrier, requires temperatures of around 10 billion degrees to surmount classically. The core of the sun is 15 million degrees, 1,000 times too cold. By classical physics, the sun cannot fuse hydrogen. The protons cannot reach each other. The barrier is too high. And yet the sun has been fusing hydrogen for 5 billion years. The resolution is quantum tunneling. Protons are not classical billiard balls with definite positions. They are quantum mechanical objects described by wave functions. A wave function does not stop at an energy barrier. It decays exponentially through it and emerges with reduced but non-zero amplitude on the other side. There is a calculable probability that a proton, approaching the Coulomb barrier, appears on the far side without having gone over the top. That probability, per collision, is roughly 1 in 10 to the 28, vanishingly small. But the number of proton-proton collisions per second in the sun's core is roughly 10 to the 56. The product of an impossibly small probability and an inconceivably large collision rate gives a fusion rate that matches the sun's observed luminosity with precision. The sun does not overcome the barrier, it leaks through it, quantum mechanically, 10 to the 28th power times per second across its core. When 4 hydrogen nuclei fuse into one helium nucleus, the mass of the helium is slightly less than the combined mass of the 4 protons. The difference is 0.7%. 0.7% of the original mass simply disappears. It does not disappear. It becomes energy. The conversion factor is c squared, the speed of light, squared, which is 9 times 10 to the 16. Multiply even a small mass by that number and the result is enormous. The sun converts roughly 600 million tons of hydrogen into helium every second. Of that, about 4 million tons per second, is converted directly into energy via E equals mc squared. Not chemical energy released from molecular bonds, not gravitational potential energy from contraction. Mass itself, converted to energy, at the rate set by the most exact equation in physics. Feynman was always careful about this. He said that E equals mc squared is not a curiosity or a slogan. It is the statement that mass and energy are the same thing measured in different units. Mass is frozen energy. The conversion factor c squared is enormous, which is why we spent all of human history not noticing that matter and energy were interchangeable. The everyday energies of chemistry are too small to produce a measurable change in mass. Nuclear energies are large enough that the mass deficit is real, measurable, and quantitatively accounts for every photon the sun has ever produced. The sun is not burning fuel, it is converting mass directly into energy, 4 million tons of it, every second. For 5 billion years, the specific sequence of reactions powering the sun is the proton-proton chain. And the most important thing about it is the rate of the very first step. 2 protons collide. One of them converts from a proton to a neutron, emitting a positron and a neutrino in the process. The result is a deuterium nucleus, 1 proton and 1 neutron bound together. This first step does not involve the strong force or electromagnetism. It requires the weak nuclear force, the force responsible for radioactive decay, which is far feebler than either. Because the weak force is so weak, this first step is extraordinarily rare. A proton in the sun's core will wait, on average, about 5 billion years before this reaction occurs. 5 billion years per proton. The individual reaction is almost incomprehensibly rare, and that is precisely why the sun has lasted 5 billion years and has 5 billion more to go. The rate of the whole chain is throttled by the feebleness of the weak force at the very first step. If the weak force were 10 times stronger, the first step would happen 100 times faster. The sun would burn through its fuel in roughly 50 million years, and complex life would not have had time to evolve. The sun's suitability as a stable, long-duration energy source is not a generic property of stars. It is a direct consequence of the specific value of the weak force coupling constant. Once deuterium forms, the subsequent steps are fast. Deuterium fuses with another proton to form helium-3. 2 helium-3 nuclei collide to produce helium-4, releasing 2 protons back into the plasma. Net result, 4 protons in, 1 helium-4 nucleus out, plus 2 positrons, 2 neutrinos, and a flood of gamma-ray photons, carrying the energy of the mass deficit. The positrons immediately annihilate with electrons in the plasma, producing more photons. The neutrinos pass through the entire sun, essentially without interacting. The sun is nearly transparent to them, and stream outward at nearly the speed of light. Right now, approximately 65 billion solar neutrinos are passing through every square centimeter of your body every second. They do not stop. You are not an obstacle. The photons are different. The solar plasma is dense and opaque. A gamma-ray photon produced in the core undergoes an enormous number of scatterings, absorbed and re-emitted, changing direction randomly at each step. The average photon takes roughly 100,000 years to fight its way from the core to the surface. Once it escapes, it travels 8 minutes to Earth. The light warming your skin right now left the sun's core before Homo sapiens existed. Feynman never set out to explain the sun, but 2 of his most important contributions to physics are directly written into the mechanism that powers it. The first is quantum electrodynamics, QED, the quantum field theory of electromagnetism that Feynman developed with Schwinger and Tomonaga in the late 1940s. QED governs the Coulomb repulsion between protons, the barrier that quantum tunneling must overcome, and the emission and absorption of photons throughout the solar plasma. The Feynman diagrams, the path integral formulation, the renormalization procedure, these are the tools with which electromagnetic interactions in stellar plasmas are computed. The precision of QED is what allows astrophysicists to predict the sun's luminosity, from first principles and have it match observation. The second is more direct. In 1957, Feynman and Murray-Gell-Mann proposed the V-A theory of the weak interaction, a specific mathematical description of how the weak force couples to particles. This theory correctly described beta decay, the process by which a neutron converts to a proton by emitting an electron and an antineutrino. The reverse of this, a proton converting to a neutron by emitting a positron and a neutrino, is the first and rate-limiting step of the proton-proton chain. The VA theory that Feynman and Gell-Mann wrote in 1957 is the direct theoretical ancestor of the calculation that tells us how rare that step is, why the weak force is weak at solar energies, and therefore why the sun burns at the precise rate that allows a rocky planet at the right distance to have liquid water for long enough for life to evolve. Feynman was working on fundamental symmetries of the weak force. He was not thinking about the sun. The sun does not care what Feynman was thinking about. It has been running on those symmetries for 5 billion years, waiting for the physics to catch up. Let me say now what the sun actually is. The sun is not a fire. It has never been a fire. Fire is the rapid oxidation of a fuel, a chemical process involving electrons in the outermost shells of atoms, releasing energy measured in electron volts per reaction. The sun operates at energies 1,000,000 times higher, through nuclear processes that have nothing to do with electrons, nothing to do with oxygen, nothing to do with combustion in any sense that word has ever meant. The sun is a quantum mechanical tunneling engine, powered by the direct conversion of mass into energy via E equals mc squared, running at a rate throttled by the weakness of the weak nuclear force, at a temperature that classical physics says is 1,000 times too cold for the process to work. The fire story does not simplify this. Dozer, the Quasiston story, the story that stories not much required. The fairy story is not Tauteract. All that story is the quasystem. The quasystem provides me for a quasystem to determine what a person's difference. It replaces it with something categorically different. A description drawn from the wrong domain of physics, applied to a process that requires quantum mechanics, nuclear physics, and special relativity to understand it all. 4 million tons of mass become pure energy every second. The sun is literally becoming less massive as it radiates. It has been doing this for 5 billion years. It will do it for 5 billion more. The warmth on your face is not fire. It is quantum tunneling through the Coulomb barrier, followed by proton-to-neutron conversion via the weak force, followed by strong force binding into helium, followed by mass-energy conversion at c squared, followed by 100,000 years of photon diffusion through plasma, followed by 8 minutes of travel through empty space, followed by absorption in your skin. Every photon that has ever warmed a human face, going back to the first living thing on this planet, arrived through that chain. Every one. The fire story never described any of it. The sun has been doing something the ancient world had no words for. Something that required the full intellectual apparatus of 20th century physics to see clearly. And it was right there, overhead, for all of human history, warming every face that ever existed, waiting for us to understand what it was. Once you understand what the sun is doing, you can ask what all stars do. The answer is that different stars at different masses and temperatures run different fusion chains and build different elements. The sun fuses hydrogen into helium. More massive stars proceed further. When helium accumulates, stars hot enough ignite the triple alpha process. 3 helium nuclei collide and fuse into carbon. Carbon fuses with helium to make oxygen. In the most massive stars, the chain continues. Carbon to neon and magnesium, oxygen to silicon and sulfur, silicon to iron. Iron is the end point. Fusing iron costs energy rather than releasing it. When a massive star builds an iron core, fusion stops. The core collapses and the outer layers rebound in a supernova explosion that scatters everything, every element the star built over millions of years, across the galaxy. The carbon in your cells was made in the helium-burning shell of a star, roughly 3 times the mass of the sun. The oxygen in every breath was made in the same process. The calcium in your bones and the iron in your blood were made in the silicon-burning core of a massive star in its final days before it exploded. You are not made of fire. You are made of nuclear fusion, in a chain of stellar generations that began shortly after the Big Bang and whose products have been cycling through galaxies, planets, and organisms ever since. When Feynman said that the atoms in us were once part of stars, he was not speaking metaphorically. He was speaking with the precision of a physicist who understood exactly which stellar processes produced which elements and at what stage of stellar evolution. The carbon is traceable. The chain is known. The nuclear physics has been worked out. You are not stardust in a poetic sense. You are the specific output of specific nuclear fusion reactions in specific types of stars that exploded at specific times. In the 1960s, physicist Ray Davis built a detector in the Homestake Gold Mine in South Dakota, 380,000 liters of cleaning fluid deep underground, shielded from cosmic rays, to catch solar neutrinos. The proton-proton chain produces a specific calculable number of electron neutrinos per second. If the standard solar model was correct, Davis should detect a predictable count. He detected 1/3 of the predicted number. For 30 years, this discrepancy, the solar neutrino problem, sat unresolved. Either the solar model was wrong, or something was happening to the neutrinos between the sun and the detector. The resolution, confirmed by the Sudbury Neutrino Observatory in 2001 and awarded the Nobel Prize in 2015, was that neutrinos oscillate. They are produced in the sun as electron neutrinos but convert to muon and tau neutrinos in flight. Davis's detector was sensitive only to electron neutrinos. The solar model was correct all along. The sun was producing exactly the predicted number of neutrinos, but the neutrinos were changing identity on the way to Earth, behavior that requires the neutrino to have mass, which the standard model as written in the 1960s had not predicted. A tank of cleaning fluid underground in South Dakota, used to test what the sun was doing, ended up exposing a gap in the theory of fundamental particles. The sun, used as a controlled neutrino source, was more reliable than the physics used to interpret it. The solar model held. The particle physics needed revision. Feynman had a story about his father who used to take him birdwatching as a child. When another child would point to a bird and say its name, a brown-throated thrush, Feynman's father would say, "Now you know what people call it. That is not the same as knowing what it is. Watch it. What is it doing? How does it find food? How does it keep warm?" The name is the beginning of the question, not the end of it. The sun is burning. That is the name. That is where almost everyone stops. What it is actually doing, protons approach each other at 15 million degrees, their wave functions leaking through the Coulomb barrier at a rate of roughly 10 to the 28th events per second across the full volume of the core. 1 in a billion encounters results in a proton converting to a neutron via the weak force, the step whose rate Feynman helped calculate in 1957. The resulting nucleus binds with others in a chain that converts 0.7% of the hydrogen mass directly into energy, producing photons that spend 100,000 years scattering through dense plasma before escaping to travel 8 minutes through vacuum and arrive on your skin as warmth. You have been feeling quantum mechanics every day of your life, not as a metaphor, as a physical process described by equations that have never failed a single experimental test, operating in the core of a star 93 million miles away and delivering its output to your skin at the speed of light. Every civilization before this one looked at the sun and named it. The Egyptians called it Ra. The Greeks thought it was a chariot. Kelvin calculated it was a gravitational furnace and got the age of the universe wrong by a factor of 50 as a result. We are the first civilization in the history of this planet to actually know what the sun is, not approximately, quantitatively, with numbers that match observation to multiple significant figures, derived from first principles using quantum mechanics, nuclear physics, and the equivalence of mass and energy. That knowledge was not given to us. It was built over 2 centuries by people who refused to stop at the name. Planck, who quantized energy. Einstein, who showed that mass and energy are the same thing. Gamow, who showed that quantum tunneling could explain nuclear reactions in stars. Bethe, who worked out the specific chain in 1939, for which he received the Nobel Prize in 1967. Feynman and Gell-Mann, who wrote the theory of the weak force in 1957. Davis, who built the neutrino detector. The Sudbury collaboration, who found that the neutrinos were changing identity. The sun is not burning. What it is doing required all of that to understand. The warmth is the same. The understanding is completely different. And the understanding is better, not because it makes the sun warmer, but because it is true. Here is the question I want to leave you with. The sun burns at the rate it does because the weak nuclear force has a specific coupling strength that makes the first step of the proton-proton chain extraordinarily rare. That coupling strength is a fundamental constant of nature. We measure it, we use it, we do not know why it has the value it has. If the weak force were 10 times stronger, the sun would have exhausted its fuel in 50 million years before complex life appeared. If it were 10 times weaker, the sun would be far dimmer and cooler, and the earth would be frozen. The value we have gives a 10 billion year star at the right luminosity around which liquid water can exist on a rocky planet for long enough that chemistry becomes biology. Feynman's position on this was characteristic. He said, "We do not know why the constants have the values they do. We measure them, we use them. We notice that they appear to be arranged in ways compatible with our existence, and we do not have a deeper theory from which their values follow." The anthropic observation that we necessarily find ourselves in a universe compatible with observers is true and insufficient. It tells us that the constants are what they are. It does not tell us why. The sun has been converting 4 million tons of mass into energy every second for 5 billion years, running on a constant whose value we cannot explain, producing a stable energy source whose stability we can quantify but not derive from anything deeper. The fire story is wrong. The real story is correct, precise, and quantitatively verified to multiple decimal places. And at the bottom of the real story is a number, the weak coupling constant that sits there fundamental, measured, unexplained. The warmth on your face is understood. The reason the warmth is possible at all is still open. Where do you think the answer is?